The story of the Avenger 3 Pro began 3 years ago, back in 2020. We had an idea to take our undisputed masterpiece Avenger 2 Pro and make it wireless, make this handsome guy wireless. So it all started with just taking a frame from the Avenger 2 Pro to simply understand what the dimensions would be, and then we put our brushless motor, which we had already developed at that time, and our electronics right next to it. The development of the motor and electronics alone took about a year, and even the motor actually took longer because we first looked for different samples, ordered from various factories, tested them all, adapted them. We found something that suited us as much as possible. Then we contacted the factory and asked them to make certain changes. Therefore, we can consider that the history of Avenger 3 Pro began not even 3 but 4 years ago. Here you can see a battery, which is called 18T500. This is the battery that most of the tattoo machine manufacturers put in. This is the most common battery type. And in the next picture, we tried a shorter version of the battery to this machine, the so-called 18350. Its capacity is 2 times less, but its dimensions are also 1.5 times smaller. Next, we measure the whole of our design, which is a sandwich of our 2 circuit boards. As our electronics do not fit on one board, there are a lot of components, despite the fact that they are quite tiny. We have our own proprietary motor control system. It is a separate microchip. Naturally, there is a microcontroller, something like a small processor, which controls all this movement, and there are tons of other components. So they can't all fit on one board. And also here you can see our motor. By the way, it is often said about the motor that it looks like some Chinese analogs. But look, the way things work in the world, there is a so-called type size. So these are some successful sizes. That is, for example, even famous German-Swiss companies that produce motors. They do not produce them in their own absolutely crazy shapes. They produce them in some accepted type sizes because they sell them to car manufacturers and manufacturers of some industrial lines. This means that they are used in factories for some robots for something else. Many different motor manufacturers may produce the same type size, meaning that the motor will be similar on the outside, but it may be different on the inside. So there will be completely different quality of components used, bearings, windings, number of turns, and other nuances. In our motor, we have these so-called Hall effect sensors, which understand the speed at which the rotor is moving and where the rotor is now. That is the part that is spinning. That's why our motor, together with our electronics, allows us to work at very low speeds, that is much lower than any motors that are now used in tattoo machines in general. It's because of these sensors. Because the system recognizes at the start that, for example, the motor is rotating very slowly, and it adds voltage there. And most of the other motors, why do they only run at high speeds? Because the system doesn't really understand how fast the motor is spinning. These Hall sensors allow us to understand the true speed of rotation. That's why we have the actual frequency written on the display. Any other machines that are on the market right now that usually have both the voltage and the frequency displayed next to one another, it's just a kind of extrapolation, so it's guessing. It is not the exact frequency of operation, but rather the approximate one. The machine is switched on under laboratory conditions, for example, at 5 volts, it gives out some frequency, let there be 70 hertz, they write down 70 hertz, then they add 5.1 volts and so on, and they write down how the frequency increases, and that's what they embed in the processor. Basically, what you see on the display is not the voltage that the battery actually sends to the motor, but the same estimated frequency. Well, that's not very correct, simply because this system will drop differently under load with different cartridges, and the electronics on these machines don't really know how fast the motor is spinning, simply because the motor doesn't have these very Hall sensors to give feedback to the system. So you can see in this picture that we've settled on the short 18350 battery bank. Since the length of it was equal to almost all of this sandwich, I mean these 2 circuit boards, the motor, the cam, and we would have a machine that would not have any protruding parts, meaning that the battery would just stand along this entire system of motor and circuit board, and the machine would be as compact as possible. This is a not very aesthetically beautiful prototype. Yes, that's how all machines start. First of all, we develop a thing that will work, that will have the most effective center of gravity, and only then we put the design on top of this whole system, so design is still secondary. First of all, it is the functionality and balance of the machine. As I myself was a professional tattooist for 13 years in a row, and my right hand still hurts, because I apparently damaged my joints badly enough. I understand what proper balance is. I mean, you can't get anywhere without it, if you don't want to make yourself a person with impairments later on. Further, we have already more or less designed how it could be in reality. So you can see here that everything really fits into the size. So it's not just a picture, it's basically a model that could be turned into a prototype, and everything would sort of work. Here, as you can see, we were planning to have a cut for the needle on the side. The screw would go to the front, the screw lock. You see here the battery is marked in blue, and accordingly you can see perfectly well that it practically does not extend beyond the dimensions of the machine. Well, that's how it would look. Well, it is clear that if we would make such a layout, we would certainly improve the design. But in general, I didn't like the idea at the time for some reason. I don't remember what it was. Then we decided to move the battery to the back. This would be the view from the top. This is basically similar to what we have now. At the beginning, it was planned to conceal the armature bar, because we thought that people would constantly use barrier protection. And as for adjusting the screw lock, I don't remember how we wanted to do it, in some other magical way. Then we thought, well, it's a bit of a fucking mess. It's too high, the center of gravity is high. We thought that we should put the electronics lower together with the motor and the battery higher, and thus bring the center of gravity closer to the grip. But I guess we decided not to. And here again you can see a return to what we have now in terms of component layout. This is apparently another redesign. And another attempt to redesign. And here you see something that has almost gone into production. It looks pretty good to me. So that you understand, from the very first photo to this one, it's probably been about 4 months. Here's the model. Notice, there are no lids here on the left side that screw on so that the battery could be removed. You can't change the battery completely without unassembling the machine. In terms of, for example, contact quality and reliability, this system is certainly superior. But in terms of flexibility, it's not very good, because the 18350 battery lasts from about 1.5 hours to 4 hours of operation, depending on the modes on which one is working. And our pro team artists, during tests of machines with these batteries, said that yes, it's certainly very light, cool, maneuverable, small, but not enough working time. Here's a little redesign, meaning it's getting more and more composed in terms of design. Here you see, I guess, such characteristic features that are very similar to the Avenger 2 Pro, some kind of a successor in terms of design. So there was an attempt to play around and put a collet lock here, but in the end we gave it up simply because in this case this system would require a very large space for itself. Secondly, it would not fit in there in terms of design. Well, and in the third, fourth, fifth place, compared to the lock that we have now, the collet system loses a lot of points. Next, one of the biggest pains in machines that aren't pens are the rubber bands, those freaking rubber bands, and how to place them. It's a real pain in the ass. I mean, you know, if you have any hybrids, the rubber bands are a pain. Here, actually, there were attempts to make some cuts, grooves, and so on, some fiddly things for the rubber bands. Here you can see how the upper part of the frame should have been cut off so that the adjustment screw wouldn't rub against this very frame, and so that it would be convenient for a person to reach in with their fingers and actually make the adjustment. This is kind of how this frame looks like inside. It was such a good weighty piece of aluminum back then. It looks a little bit different now. It's just, you know, what a cool design, I think. Notice there's the bend we have in the back for the rubber band. With a smaller bend, the rubber band would come off in our tests. You can't see all the prototypes here, unfortunately. I didn't keep a lot of the pictures. A lot of different prototypes were made. Here you can see that there is a very strong bend for the rubber band. Then there was an idea to make this groove in a different way, to redesign it in a different way. There was even an attempt to make some ledges and to understand how the rubber band would be held on them. In our prototypes, by the way, the rubber band used to go in the area between the display and the control buttons. Of course, it did not look very good, but in general it worked. And accordingly, to keep the rubber band from slipping off, there are all sorts of cuts and tricks. Again, this edge must not be sharp, otherwise the rubber band will be torn. There were even variants like this. Here you can see how the rubber band lies on the 3D printed version. Well, let's just say it doesn't lie very well here. Apparently we marked some other artifacts for ourselves, some little bugs that came out. As you can see, the groove for the rubber band has already shifted backwards. At least the rubber band didn't fall off from there, it didn't roll down. That's the other option I had for the rubber band, like this one. Here you see a 3D printed model. We've made a huge number of such models with all sorts of changes, and we tried on rubber bands and other nuances to understand how it would be in real life. You know, not to make prototypes out of aluminum because it's long and expensive. We first used a 3D printer, which is now a very common solution. Here you can already see this handsome guy in aluminum lying next to the Avenger 2 Pro. You can see that in fact it is not much bigger. This is right here, probably one of the first working prototypes, which were already given to the Pro team. See, even the screws are different colors. When we make alpha test machines, the very first ones, we don't think much about the appearance. There are other things we care about first. We need to make sure that thing doesn't fall apart at all, doesn't stick anywhere in the hand, and that everything will be fine. This is the machine we had, probably less than than a year after the start of this project. And for you to understand, we were naturally developing other things in parallel, like the third generation of Ultron pen, polishing the current machines, and some other projects were being developed. If we had focused on this machine only, I think we could have launched it earlier, because it was actually ready by the end of 2022, but we're launching it at the end of 2023 simply because we decided to release Ultron 3 first. And only then, after Ultron 3 was launched, we started the production of this machine. And launching production is quite a time-consuming thing, which can often equal the development time with all the prototyping and testing. These must be some attempts to play with the rubber band channel again, because as far as I remember, this topic has been on our minds for a very long time. There was no way to make it suit me, because I, as a person who has worked with coils for 13 years and knows everything about rubber bands, I directly demanded that everything was okay with them. And here we also paid attention. I think it's just Max Titanic at work. We have noticed here how the rubber bands lie on top of the Avenger 2 Pro. They're laying on top of the logo. I don't really like this. I would like the logo to be visible. Accordingly, that's how the idea for the stabilizer was born. For a very long time, we did not want to complicate the machine with additional 2 bearings with a clamping system, simply because the more units in the machine, the more likely it is to break. Well, that's how it really works. There have been variations of these clamps. Just so you understand, our needle stabilizer is quite intricate, even though it looks very simple. Well, you can see how smoothly it works. For instance, you are tightening the tube lock, but the stabilizer itself stays in place. You can slightly tighten the lock. Then you can slightly adjust the degree of tension you need with your finger, and then tighten the lock all the way. And at the same time, the stabilizer will not go forward and will not squeeze the needle, simply because there are certain nuances. Let's say that a lot of brain power has been spent here to make this thing work well. Those bearings that are used here, they've been thoroughly tested as well. The size was selected, and this whole combination works well. This is a little bit of a different design right here. We usually choose something from several designs. Then we change it multiple times, refine and polish it. Here is probably the almost final design. This machine has already been approved. However, we did not proceed with production, and now you will see why. Because I wanted to redesign it. It seemed to me that it was already too angular, and the design trends have slightly shifted in a different direction now. So, we need more square things rather than sharp angles or those we made in coils 10 years ago. From this perspective, I wanted to make it completely square. Now look here. The idea to create a lid to change the battery was born here, but not to change it to charge one in the charging station and insert another. It's for slightly different purposes, which you will see a bit further. Here you can see how the system looks with the lid. A small lid is used here, which covers a more compact 18350 battery. For you to understand what is 18350, 18500, 18650, the first 2 digits are the diameter and the last 3 digits are the length. So it's 18 millimeters in diameter and a length of either 35 millimeters or 5 centimeters, or respectively 6.5 centimeters. Here you can see quite sharp edges at the bottom. And when our main industrial designer Pavel Grinder, a Sadakaya, who is also a tattoo artist and a member of our pro team, a well-known ornamental tattoo artist, worked with this prototype, he said that this thing hurts the hand. Therefore, there will be some changes in this unit a bit further. Here we also did something with the design to make it less sharp. See, now on the left there is a machine with an 18350 battery, and on the right with 18500. The one on the left can usually work for a maximum of 4 hours, and the one on the right can usually last up to 7 hours. The minimum operating time for the left machine is 1.5–2 hours in some aggressive modes. The one on the right, well, 4 hours. Under aggressive mode it can last about 3.5 hours. By aggressive modes I mean 4.7 mm 5.5 mm strokes at high frequencies of 100 Hz, 115 Hz. Then indeed the battery quickly drains. But in reality, few people work at such frequencies. For example, we haven't encountered somebody working effectively with 5.5 mm above 85 Hz. We conduct regular surveys on how people use these machines, what they do with them, at what frequencies, on what strokes. Usually people don't go extreme because the machines are already powerful enough, so why bother? This is how they look from the side with different batteries. Again, a top view and a front view. As you can see here, you also see vise locks that are the same as those installed on coil tattoo machines for a long time. They are all scratched up here, but these are prototypes. Don't judge them harshly, they have no processing at all, simply because there were a huge number of versions. There were no less than 100 changes to these drawings. Here we have something not matching, some misalignment in the prototype. We're addressing that issue. Here it is clearly visible. Moving on, again some small redesign, some changes. I'm not going to read out the changes for you right now. we have a huge timeline of changes, and it probably won't be enough even for a 3-hour film if we explain why and what changes were made at any given moment. This is how another prototype looks, you see. They may look very similar, but some really key things can change that may not be visible. Perhaps something inside the drive system was changed. Here, some parts for this machine came to us. We rejoiced like children on Christmas. So, we decided to make a different screw here. The guys convinced me. I wanted to stick with our classic, but for some of our particularly sensitive friends, it was still pressing on the hand, hitting the finger if you didn't turn this pea-sized screw carefully enough. Well, plus, I decided to switch to a more modern lock. You see, with this little lock, everything really looks much better. This is how the inside of the sandwich of all these boards is arranged. The special spacers marked in red are individually milled and inserted so that when you press the button, the entire structure, all these boards, does not compress or break inside. The button can be pressed quite hard. The entire system must withstand the load. So here you can see that there was probably another redesign for the locking mechanism because we made 3 different sizes of these prototypes, sent them to Pro Team, and they chose the size of the screw that fits them best. You see here a bit smaller, here a bit larger. Here, we are choosing the transparency level that the top screen should have on the display. It's visible that the film on the left is not translucent well. It's from our PowerBox 5 Pro power supplies. You see, it's not very transparent. Here, there are also some nuances, either something rubs against something or something else. So this is one of, in my opinion, almost final designs. These are the sharp edges that we decided to round off. This too, you could say, is almost the final result. Handsome, isn't it? These are some photos of how the contacts are arranged because we tried to make the lid as compact as possible. And there's a small nuance in this because aluminum is not an ideal material for use as current carrying terminals. So we had to work very hard to make the contact normal. But if, for example, you receive the Avenger 3 Pro machine and it suddenly doesn't turn on, just take it, unscrew the battery cover and screw it back on because an oxide layer forms on aluminum and it acts as a dielectric, meaning it does not conduct electricity. But this doesn't happen often. Just if it happens, don't rush to think that the machine is broken. It's enough to occasionally unscrew and screw it back on. For those who may not handle machines very carefully, in terms of getting them dirty, perhaps spraying them with some toxic solutions and not cleaning them. There, maybe all these lids get clogged with some dirt, and then you need to clean it periodically. But this is assuming that you constantly unscrew and screw it back on, and some dirt gets in there. Here, look, there's already a discussion going on. I'm sharing with the guys a version of the new design where I eliminate all these corners and make everything as straight as possible. You see, it already looks like what we have now. And the machine really starts to look fresher, I would say. It's more in line with modern design trends. Next, we conducted surveys among our Pro team. There was approximately, I think, a 50-50 distribution of votes. That is, some voted for the left design, some for the right. But in the end, I chose the right one. Here's our old design. You see, it's also a beauty. Some of the Pro team still have these prototypes and they use them, so these machines have been working for 2 full years and feel great. Well, you see here too, this sharp edge is marked. There's some nuance here too. And then look at this beauty. I've wanted to create a system that counteracts the cartridge membrane for a long time, and here it is. These are 2 magnets that in fact almost touch. There's a distance, a gap, about 1 millimeter, sometimes up to 1.5 depending on the stroke. These are 2 magnets that attract each other. Here's what happens. At the moment when the armature bar is in its lowest position, the cartridge membrane is fully stretched, meaning it presses back with maximum force. And just when the magnets are positioned as close to each other as possible, they attract each other with the maximum force. So essentially this system that we called anti-gravity can counteract the cartridge that is pressing upwards and hindering the motor from lowering the armature bar. And this anti-gravity system additionally strengthens the hit at the very bottom. It adds force to both the motor and the entire system. So as a result, the hit at the bottom of the amplitude is sharper because there is not such a strong deceleration as when there is no anti-gravity. It doesn't affect the hit very much, but all the systems contribute a bit when put together. Plus a powerful motor, plus these speed maintenance systems, anti-gravity system, and then there's also the connecting rod, which plays a little at high frequencies. All these systems together still make the machine work a little differently, and people like it. The feeling that it packs the lines a little faster than some ordinary rotary is cool. Then here we have our own discussions, so that you can see and understand how this whole system looks, filled with a bunch of different stuff. There are more parts in this machine now than in any other wireless machine on the market. Here, take a look at this prototype. Here we tried to use a rubber band between the lid and the frame. We thought maybe it would be more fun. And here you see the version of the machine with the lid for 18,650 battery. This system here can run for up to 12 hours on some of the lower modes, so that's just crazy capacity. But there are fans who say, I want to charge 1 battery and run for 2 days and not worry at all. I don't care if it adds an extra 10 grams to the weight of the machine. This is what it looks like from above. In reality, it only appears to be creepy. I've personally held one myself, looked at it, and it feels remarkably okay okay in my hand. Yes, it's a little heavier, yes, a little sorta worse balanced than the version with the shorter battery. But in general, it's perfectly normal. I mean, it's not like it's going to break your arm off. That's basically what the machine looks like now. And now guys, what we've got here is a handsome little chap with an amazing balance. There's really nothing like it. I mean, this is the most fully functional wireless machine that exists. It's a real multi-tool in the tattoo world.